Topic as was assigned was decimal to octal and octal to decimal, and there were two methods that were taught in class. Method 1 dealt with converting from decimal to binary to octal, which was not my topic, so I only chose to explain method 2. Method 2, first step, was to take the decimal number and divide it by 8. You would then take the quotient of that and the remainder, and then you would place it into an array of quotient and remainders next to each other. Then you would take that quotient number and then you would divide that by 8 and result into a next quotient number and a remainder. You would take this number 2 step and then you would repeat it until you get a quotient number that is equal to or cannot be divided by 8 and equal to 0, and which the remainder would actually equal to the previous quotient or could be thought as just the end remainder. And then you would continue on, and if you want to write a chart, the chart would look like quotient number and remainder number having the x amount of remainders and the x amount of quotients, and the last remainder would be equal to the previous quotient of the last or just the overall ending remainder of x. Then you approach the balloon property, which means that you just start from the bottom to the top, and means the remainder, the last remainder would become the first digits, and the first remainder would be the last digit of the number. And in which case, written down, it would look like last remainder, second to last, third to last, etc. to first remainder would be the last digit. And you would write that in base 8. We have an example of convert 340 base 10 to base 8. So we start with our first, and we have 340 divided by 8. We write down the quotient number, remainder number, and we write down the quotient is actually 42, remainder is 4. We take 42 divided by 8 again, which equals 5, with a remainder of 2. Take 5 divided by 8 equals 0, and then we know that would be the previous quotient divided, which is 5, which is also the end remainder. And then you would use the balloon property. So we start from the bottom, the last remainder we have, it equals the first, the second becomes the second digit, 4 becomes the third digit, and we have that as base of 8. Easy and simple. We then continue to the reverse side, which means that we convert from octal to decimal. Okay, so octal to decimal is basically you're using multiplication instead of division and different implications. The first step would be to write down the powers of 8 that correspond to a number of digits in the given octal number right below the actual octal number given. And in any case, it would look like octal number would be the dashed lines are the digits, and the powers of 8 right below it. Assuming it's not a decimal, that is what it would look like. We then would place each digit into a parentheses, and then we will multiply each digit by the corresponding powers of 8, and then that we would add everything up, and that would be the answer of base 10. The question would be, example would be convert 524 base 8 to base 10, which is the previously mentioned problem. So we got the first step, octal number 524, and we write the corresponding powers of 8 right below it, and then we would do multiply everything out. 5 times power of 8 to 320, 2 times 8, 16, then 4 times 8 to 0 power is 1 equals 4. We add everything up, equals 240 base 10. If we go to the back, we can actually check that this is actually fully correct, and it actually does work. And that is all. These are all based on Miss Lambort's lesson, and it's by Kendra Chow, and I hope this helps.